Hello, moving on from the last question, uh, that if there is a bullet and there is a target here, and suppose this gun is fired at an angle theta, right, and you fired with this velocity u. Now, because gravity will bend the path, however how much fast you guys project this, there will be a bending, okay, and so it may go like this, it may go like this, or it may go like this depending on its speed. But because this target, let us say some height is involved, h height above, because h is greater than 0, means because the motion has to take place in y direction, gravity will bend the path, so you will never hit the target. Now I asked the second question, that if this target undergoes free fall, so as you fire the bullet, at the same time, so this is target, at the same time it goes under free fall. Now from the last question we can relate, if target goes under free fall, at the same time when this bullet is fired with velocity u, then what will happen? Target will fall by half gt square. In time t, the target will fall by half gt square, right? You can find this using kinematics equation along y direction. Now this, if there is no gravity, then you know that the bullet will take this path, but because there is a gravity, this bullet will also fall by half gt square. So what happens if the target falls, it's under free fall, and if at the same time you launch the bullet, they will both hit, no matter how fast or how slow you are firing. If you are firing very fast, they might hit here or here. If you are firing with low speed, they might hit here, but it turns out that they will hit. So this is a famous problem called monkey gun problem, and I guess experimentally it can be proved also, not with monkey but with some target. And the story goes like, in South Africa, that they used to kill monkey. Okay, this story I have heard. So as they will fire, by listening to the sound, the monkey, they will leave the tree, they will undergo free fall. So during that instant they used to get killed. So if monkey sits here, when the bullet is fired, nothing is going to happen. But when monkey let a branch of tree goes, okay, at the same time when he sees the bullet or when he hears the sound, then what happens? They will get killed. But whatever, this is our target, we are not calling it monkey, so they will collide. Again, I told you, for collision to happen, this is my origin, let us say this is x, this distance is x, and this distance is y. So x and y coordinate should be same at the time t. So what happens? X is, along x you can use u cos theta t, fine, it has traveled this much distance, so it turns out that it will hit it. Okay, now the next question we are going to do is, suppose you have steps and a very small ball is projected with velocity u, and it falls here, then it falls here, then so on, right? So it is a projectile motion. Just you can imagine it is projected with some speed, and just imagine that the size is such that it falls here, then again with same speed, because there is no acceleration along this direction, we are ignoring friction and all, again it repeats the same motion, right? Now it is given that each step height is h, okay, this is h, and it is b meter wide. So it is also given that, so a ball is launched with initial velocity u, height is, each step height is h and width is b, it is wide b, so this distance are b. The question is, okay, so this n, h, b, sorry, these things are given to you. The question is, the ball will hit the edge of nth step if, and you have been given options, now here everything is given. You can see here g is acceleration due to gravity, so you have to find. Now this question looks very complicated, right? But this is nothing but a projectile motion question. So if we can select our origins, let us say this is our x-axis, this is y-axis, right? This is our origin, let us say, and let us say this is nth step, okay, this one is n step. Now when it, okay, this is our nth step. Now if the ball will reach here, let us say here, okay, fine, it reaches nth step, edge of the nth step, then it will travel this much distance along x and it will move vertically through this much distance y. Okay, I am not writing negative because it will not matter. Okay, if you use sign properly, then everything will come out. So what will be the value of x? So you can see along x each is b meter wide, so I can write this x is going to be equal to, x will be equal to nb, right? B along x, so you add n times b. Along y, again you guys can guess, it is going to be n times h, okay, vertical distance. Now we know that along x there is no acceleration, so this, let us say it arrives here in time t, okay, so in time t it hits nth step. So x will be equal to ut, because if you can recall, x equal to ut plus half at square, but there is no acceleration along this direction, so x will be ut, and what will be y? Y, there is no velocity along y direction, so again ut plus half vgt square, it will give you this. Now some of you might think why I have not used minus sign. So see, in this case this will be minus y, this is my origin, so this is minus y, and this is minus g, so minus minus will get cancelled. Okay, so I can use the sign convention also, no problem. So minus minus will get cancelled. Now the problem is solved. Since this answers does not involve t, you have to get rid of t. So t can be calculated as x by u. X is nb by u. So y half g, t is n square b square by u square, right? T is this, so t square n square b square by u square, and y is again not present, y is nh, so nh is g n square b square by 2u square. So this n and this power of n will cut, so n will be 2u square h by gb square, 2hu square. So this option. Now last question I am going to discuss. Now the question is, if t1 and t2 are time of flight for same range r, then so if t for same range r, then t1 t2 is directly proportional to r square, t1 t2 is directly proportional to r, t1 t2 is inversely proportional to r, and d t1 t2 now so how you can have okay, for same range we know that if you project anything with velocity u, right now at an angle theta, then this range, this distance r is given to be u square sine 2 theta by g. Now we also know that if you project something at theta, then you project at 90 minus theta, then ranges are same. So range at theta is equal to range at 90 minus theta, right? So we know that suppose first one is projected with angle theta, u is same according to question, they both are launched with the same speed. Now time of the flight, you know that time of the flight is given by 2u sine theta by g. So using this, t1 will be equal to 2u sine theta by g, and t2 will be 2u sine 90 minus theta. Okay, first one is projected at theta, second one is projected at 90 minus theta. So right, so 2u sine 90 minus theta by g. Now it turns out that sine 90 minus theta is cos theta, so t2 is 2u cos theta by g. So this is, now if you multiply them, then you will get, so t1 multiplied by t2 will be equal to, so just multiply t1 t2, you will get 2u sine theta, right, 2u sine theta by g into 2u cos theta by g. So you will get to be 4, okay, let me write it, 2, okay, 4 u square sin theta cos theta by g square. Right. If you remembered, uh, 2 sin theta into cos theta is equal to sin 2 theta. So 4 is there, 2 I can take, so T1 T2 will be equal to 2 u square sin 2 theta by g square. Right. Now, so you can see in this case, this is nothing but T1 T2 2 by g, I can write it, and this is u square sin 2 theta by g. So this is nothing but range. So you will get T1 T2 is equal to 2g. G is constant and times r. So T1 and T2 is directly proportional to r. This will be correct. This is constant. Right. Now, thank you.